Okay, the last special case that we're going to be doing is going to be the difference of the sum of cubes. So it's very similar to the difference of squares, except for the fact, of course, that there's a cube, and we can do it with plus and minus in this case. The difference of squares is only done with the minus in the middle. So here are the forms, and what you can remember is that the a plus the b, that first part is always going to have the same sign as the original sum of cubes. So the subtraction is the subtraction here in the same. The other one is the one that flips. Okay, so addition here, subtraction there, subtraction here, addition there. And the rest of it is all the same. A squared, AB, B squared. So this is just something that you are going to have to memorize and understand, because we do not know how to fact cubics other than these ones right now. So let's go ahead and do an example as negative a cubed plus 8. And what I'm going to do is I'm going to do it in two ways. Okay, the first way is I'm going to factor out a minus 1 and write it as a cubed minus 8, which then can be written as a cubed minus 2 cubed, because 2 to the third is 8. So what we get here by plugging into that equation is this value, that's a, and the 2 is the b. So if I plug directly into the formula, again, a minus 2 times a squared plus 2a plus 2 squared. And that's the end. So once you have the a and the b value, just plug it directly into each of the places that it's supposed to be, and you get your answer. Now you do need to check whether or not this is factorable or not, because it is possible that you could factor this. But the factors of 2, or 2 to the second is 4, is 4 and 1 and 2 and 2, and none of them add or subtract together to give you the 2 in the middle. So this is another very handy reason why you should be learning how to do guess and check, so you can do that really fast. So let's do the other way. The other way is to leave the problem the way that it is and just change the order. So, meaning like that. Because again, addition is commutative, so I can change the order as long as the subtraction stays attached to the same number or variable. Now, what we get here is 2 cubed minus a cubed. So what happens here is our a's and our b's flip. So meaning this is an a, and this is our b. So when we plug into our formula up there, what we get is 2 minus a, 2 squared, plus 2a plus a squared. And then you can rearrange it if you want as negative a plus 2, and then change the order of that one as well as a squared plus 2a plus 4. And then if you factor out a minus 1 from here, you get the same answer that we started with. So just like in the one we did with the squares, we want to be able to take the numbers which are in front of the cube and then convert it into a cube as well. So this one is 2 cubed, a cubed, plus 125. And again, when you have exponents like that, you can bring them out as a single exponent. And 125 is 5 cubed. And this is going to be our a value. And the one on the right, 5, is going to be our b value. And again, plug into the formula for the sum of cubes this time, which is going to be 2a plus 5, which is going to be 2a squared minus 2a times 5 plus 5 squared. And again, simplify it or expand it out so that you know that it is not factorable. 2 squared is going to be 4a squared minus 10a plus 25. So 2, 2, 5, 5, So this one is factorable. And you can write it as 2a plus 5 times 2a minus 5 times 2a. Oh no, that one doesn't work, right? Minus 10, minus 10. So that one doesn't work either. That was too big. And this one also has 25 and 1, which would give us numbers which are too large. So this one failed because that gives you negative 10a, and that one also gives you negative 10a, which gives you minus 20a in total. I just thought that it added up together because all I saw was 5 and 5 in my head. But this one doesn't factor anymore. And we're left with that. Okay, for the last problem, I want to show that what you can do when you're doing these is also factor out the GCF, right? That is still the first thing that you should try to do. So here, in common, what they have is a y. Now, you can also factor out a 2. Okay, that is possible. I think you probably could factor out a little bit more than that. But if you could see already that this is a cube, and what would 64 be as a cube? So let's try it. So we have a 4 there, a 4 there, and a 4 there. So this is going to be 4 cubed. So let's write this one as y 10x to the third plus 4y to the third. And now we have a difference, sum of cubes in the middle, which gives us y times the first plus the second, the first squared minus the first times the second plus the second squared. Okay, and then write it out. Okay. And again, test to see whether or not this is factorable. This one would take a little bit more work, but it is not factorable.